Okay, I would like to take a moment and take some time and talk about negative exponents and subtract and the relationship between the quotient, the divisions rules where you subtract the exponents. Okay, ideally we want to avoid negative exponents for variable expressions. Now, why these are connected to the way they are? Let me take x to the fifth, and I will divide it by x cubed. And I'll do y. I'll leave this the way it is. This would be equivalent to x times x times x times x times x. Okay? Over x times x times x. Okay? And these would cancel. Okay? Notice that what we would do here, this is actually going to be x squared over 1. Because everything canceled down here, so that gave me x squared. X squared divided by 1, x squared divided by 1 is just x squared. Okay? Now, what we would have done following this rule, since the degree on the exponent was higher on top, I would have done the subtraction here. X to the 5 minus 3 is x squared. Okay? Let me give you illustration number 2. X to the 4th over x to the 7th. That's going to be x to the 4th, x times x times x times x over x times x times x times x times x times x times x. Okay? Cancel, 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 cancel. And all these are equivalent to 1. Okay? I could have done the same thing up here. Okay? So, the thing is that you cannot leave a numerator vacant. So, this is x cubed down here. You have to include a 1 if everything, x cubed down here. You have to include a 1 if everything cancels in the numerator. Okay? And what we would have done here is we could have done, we use the one that avoids a negative exponent. So because the power down here is higher, I would have done x to the 7 minus 4 and left the 1 up there, following that rule there. Okay, so that would have given me 1 over x cubed. Or, if I had used this rule here, this variation anyway, I would have gotten x to the 4 minus 7, which gives me x to the negative third. So, 1 over x cubed is equivalent to x to the negative third. And now you see the reasons for this rule right there. Okay? So let me get these off the board and do some examples. All right. Example 1. 5, x to the second power, y, over, let me make that x to the 12th, over, I'll make that 15. This will be 3x cubed, about the 5th. 3x cubed, 3x to the 5th. And we're going to do y to the 9th. Okay, I'm trying to avoid repeated numbers. Okay, so here goes. 15 divided by 3 is 5. Now, because the power of x is higher up here, I would do 12 take away 5 up there. Now, for the y's, the power of y is lower down here. So we do 9 take away 1. And that gives me 5x to the 7th over y to the 8th. Okay? Example 2. Let's say I have 5 30ths. A to the 4th a to the 9th. Well, what's going to happen here, and let's do b squared. Okay, so 5/30ths reduces to 1/6 as a fraction. Now, down here I have a to the 9 minus 4th, because the power of a was higher down here. And the b squared will be unaffected. And that would leave me 1 over a to the 5th, 6a to the 5th. Okay? I don't need to write the 1 if there's already something else there. So 1 times b is b. If everything had canceled, I would have needed to have left a 1. What do I mean by that? Well, how about this? 2/14 x over x to the 9th. Well, 2/14 reduces to 1/7. And then the power of x is higher down here. So 9 minus 1, subtract the other exponent, I end up with 1 over 7x to the 8th. Okay? Example, remember, a numerator cannot be blank. Okay, you have to have 1 if everything's gone. Okay, let's talk about maybe a rule like this. Let's say I have 5a to the 8th, b to the -2nd, over 22. Well, what's going to happen is this will be left alone since these two don't need anything. A to the 8th isn't going anywhere. But b to the -2nd is actually going to go to the other side of the fraction bar, and the exponent will now become positive. Okay? Example 5. 10/12, and I have x to the -4th, y squared. And up here I have a to the -3rd, b to the 6th. Well, these two would reduce like normal to 5/6. And then I'm going to have, for this one, I'm going to have a cubed will go down here at the bottom. Actually, why don't I do it this way? So 5/6 stays this the way it is. These two are going nowhere. They have positive exponents. Okay? This is going to the other side of the fraction bar, and it will become a cubed. This is going to the top. This is going to be x to the +4. Now, it's customary to write in terms, it's customary to write the variables in alphabetical order. So this is going to be 5b to the 6th, x to the 4th. Down here, I'm going to have 6y squared, a cubed. Okay? Let me get these erased. Example 6. Let's do 20x to the 8th, y to the -2nd, over 4, x to the -1st, y to the 5th. Okay, what I'm going to do is 20 divided by 4 is 5. And these two go nowhere. X to the 8th, y to the 5th. This is going to go up to x to the 1st, become positive x to the 1st. And this y to the -2nd is going to go to the bottom. So I'm going to now multiply these. This will be 5x to the 9th. This is going to be y to the 7th. Okay? You will have situations like that. Okay? Example 7. 2x squared over 3y both to the negative fourth. Well, what you can do is we'll apply the top and bottom, or we'll apply the exponent to both the top and the bottom. Okay? And then these two are going to go to the other side of the fraction bar. This is going to be 3y to the fourth over 3y all to the positive fourth. This is going to be 2x squared also to the positive fourth. All right, so I'm going to take this to the fourth like I normally would. 3 to the fourth is 81. 4 times, and then we're going to multiply. Well, y to the first, you multiply the exponents when you raise exponents to exponents. This will be y to the fourth. Okay? Down here, 2 to the fourth is 16. And 4 times 2, because we're raising exponents to exponents, we multiply. 2 times 4 is 8. X to the 8th. Okay? Example 8. Let's say I have 4. Let's make this 6/3. 6 and 4. X to the fifth. X to the negative second. Y to the 8th over y all to the negative second. Okay, now what you're going to want to do is I would simplify everything within the fraction first. So this becomes 3/2. And the x to the fifth goes nowhere. Y to the 8th goes nowhere. Okay? And down here the y goes nowhere. X squared goes to the top. And this is still going to be the negative second power. Okay? And now we'll continue to simplify the fraction. So this will become 3. X to the fifth times x squared is x to the fifth times x squared is x to the 7th. And then the 2 goes nowhere. Okay? Y to the 8th divided by y is also y to the 7th. This is going to be to the negative second. And then I would proceed to do what I did here, which is to do 3x to the 7th, y to the 7th, squared, negative 2, over 2 to the negative second. And these will go to the opposite side of the fraction bar, and I'll make the exponents positive. So this will be 2 to the positive second power over 3x to the 7th, y to the 7th, squared. Okay? They switch sides and the exponents become positive. So the end result is I have 4 over 3 squared is 9. 7 times 2 gives me x to the 14th and y to the 14th. All right, and that's it. Got negative exponents.